Okay, today I would like to present you about the water purification for a small village. So my presentation present you with a series of episodes with a lack of statistics and data. So probably, I hope really this type of approach actually leads some kind of domino engineering which could be propagated into a systematic approach to solve water, wastewater, and even sanitation problem. So we have a problem, of course, we know from the morning session. So my story actually goes back to 2006. The students of my the university went for the project into the Siem, Angkor Wat, and Cambodia. They found a lot of problem with water. When they came back and they actually discussed with the faculties, they would like to provide some very small solution, even for children. So we made one and to send them to make a safe drinking water. Okay, so they experience a lot of actually pathogen and turbid water. So that's why we use microfiltration at that time. As you know, Korea is a small country, so a story was told. So another actually the priest and a Catholic priest and a missionary called us and to make another one so that they can use these types of small purification system to bring them to the Kenya. So the day we asked them to send the water to us to measure water qualities, we found the water in Kenya was contaminated with the nitrate and especially the mercury. At that time, we designed this water purification system with the nanofiltration membrane. So, after that, we would like to make some kind of project, systematic approach to make engineering and technology to be used for the further project. So we name that as Ongdal Siem. Ongdal Siem in Korean language means foundation, which can produce the fresh water in deeper forest. So we name it, and it should be very simple, and it should remove effectively a lot of the contaminant, including pathogens, sometimes arsenic, sometimes mercury. So it should be maintained without any significant actions. So we can design and make Ongdal Siem so that we can replace membrane every 2 or 3 years. So when we send the unit to the site, we send the extra membrane so that they can use these types of the unit for at least 4 to 5 years. So we make this one and then try water qualities to make a safe drinking water by substituting sometimes nanofiltration, sometimes microfiltration, depending on water qualities, depending on their situation, depending on their operator. Sometimes children do operate this one, sometimes adults use this one. Then we test it depending on water, depending on their situation, like this one, then with a different design. So sometimes we made hand rotating pump, sometimes a bicycle pedal, sometimes the other. So we made this one to send to the actual site to make a safe drinking water. So a specification of the Ongdal Siem is very small, so 30 kilogram, sometimes big. So the making these types of the sample system is one, but delivery is another important thing. So we would like to make this one as compact as possible. So with nano Ongdal Siem, we can make about 3 tons per day. Micro Ongdal Siem, we can make 10 tons cubic meter per day. So so that approximately 200 person or 1,000 residents can use this one for their drinking water. So there are 2 different types of Ongdal Siem. Nano, to remove heavy metal mostly, nitrate and organic contamination, sometimes arsenic. Microfiltration ongdarsem, we name that as micro ongdarsem, designed and made to remove mostly pathogen and turbidity. So we've been getting feedback from the site. So when they satisfy, they send the letter. If they have a modification, they also send the letter for us to modify our system depending on situation. So let me show the couple of example episodes with ongdarsem. First time, the Cambodia, Angkor Wat for their children. So we made it micro ongdarsem to remove pathogen. So after the Kenya, missionary called me once again, as I mentioned earlier, to remove their nitrate and mercury. So the Catholic father called me one time. So for their site in the South Sudan, so that their water contaminated with the pathogen. So we designed this one. This is a picture from Sudan. So they used the bicycle pedal to pump all the water into nanofiltration membrane. So it looks like they happy. So the ID, after disaster, the Korean NGO, so they asked us to make this one to make a safe drinking water during the rescue activity to make their own drinking water. So Vietnam, so we have the capacity building inside the campus associated with the UN University. So the Vietnam students came to my university to study. So these types of approach, these types of project that can help the students to design, to study, and to educate themselves with these types of approach to solve drinking water problem in the Vietnam contaminated with the arsenic from Mekong River. Mongolia, at this time, the Buddhist monk called me. So a lot of religion, I believe. So that they called me to make this one because they experience hardness problem, manganese and the calcium. So we made it. They have a ceremony, and they interested in their broadcasting interest in that project with ongdarsem. So another one for Malawi in Africa. So one professor retired from artistic college. She would like to bring this ongdarsem with her to Malawi to serve in there. So in there, she sent the photo with the persons. So Philippines, they experiencing the difficulties with the heavy metal. So we send them one. Zambia, another pathogen problem. So the Laos, and actually our students bring all the compartment. So they're using airplane. They assemble inside. So with their residents to make this ongdarsem and educate them to how to use it, sometimes to maintain the system. So lastly, IT. So after disaster, there is one the orphanage in IT. So for them, we designed one to send them to use to provide the safe drinking water, like this. So with this, the project we present the two elementary the students. They so actually very interested in these types of the project. So I made the safe drinking water from wastewater. Okay, using the ongdarsem. So I asked them who actually tried to challenge to drink this water from ongdarsem, from actually wastewater, but actually not. So with some color. So a lot of children voluntarily sort of attempt to drink this water. So we would like to give them some vision, making invisible to the vision, of course. So we are also attempting new types of the ongdarsem with the new the membrane. Please display the photo motion picture, please. Yes, right now. Yes, video. Yeah, thank you. This motion picture, that we would like to use these types of membrane without any pump, just to use the hydraulic head, gravity membration so-called. So we just soak membrane into the water. Then we can make drinking water when the water contaminated with the mostly turbid and pathogen. So it works. So we made one Ongdal Siem with these types of membrane to send it to the IT, the latest one made with these types of the membrane. Okay, continue. Yeah. Okay, so then whenever we make these types of water purification systems, so we are also interested in another contamination. So we would like to solve another problem of the wastewater and contamination with the toilet systems. So to narrow down node to gap, so from morning session, so we strategically design a village, which is a pilot village, having 23 houses equipped with a separation toilet system. But when you actually operate this system, so we actually designed a ventilation unit to operate this one without any order. This is actually my house in Jiri Mountain in Korea. We've been operating these types of toilet without any the water. Okay, so we use just a ventilation unit. From time to time, every month, I get into that separated room to collect, okay, the dried the feces. So every month we can collect this one to move to the vegetable garden. Also, we are also separating urine using these types the water to be diluted with rainwater. Also recover the water from wastewater treatment wetland. Also from a sink, separate the sink in kitchen. So we every house has the two different sink, one with detergent, the other one without detergent, connected to some tank to be diluted with the urine to be distributed for our vegetable garden. Okay, without the feces and urine, so we have only gray water, relatively clean compared to normal wastewater. So we use just this the engineered treatment wetland to treat gray water to make these types of affluent water qualities. So we've been successfully operating these types of that. Then we use these types of treatment wetland. So combine every engineering concept on our idea. We separate the feces to be transformed to the composite. We also separate the urine to be distributed for our vegetable garden. Also, we have an engineering idea to feed our some kind of microalgae, okay, to grow. They're using the algae farming. And from there, we can extract the lipid to be transferred into the biodiesel. So we are now performing these types of project right now. So probably we can hopefully operate these types of unit, okay, associated with treatment wetland. Then combine every engineering concept to be applied for the rural area. Of course, we can, hopefully we can use these types of cell of the combination of technology for even the metropolitan area for separated district, the cell of the houses, even in metropolitan such as Seoul. Thank you very much for your attention.